All right, so I decided to do a part B. So what we're going to do is I want to revisit example one and uh, finish it in terms of uh, figuring out uh, what B hat is, as well as how close is it to B. So this is where we left off from example one. We went through the work and we were able to find X hat is uh, 1, 2. And the part that I had left off is, well, let's use matrix A multiplied by X hat, and let's see what that gives us. It would be nice if it would give us B. That's not possible. So in this scenario, B hat is 4, 4, 3. Ready? So the idea is this is the best you can do. The, this is as close as you can get to B. How close are you? Well, the distance, with me, the distance from AX hat to B is what we call the least squares error, right? It is an approximation. So to find the least squares error, can be done by just simply finding the distance between the desired solution, B, minus the best solution that you can get to, which was AX hat, right? So the desired solution, and we're going to find that when we're done, we're going to find the magnitude of this. Minus 4, 4, 3. All right, that gives us -2, -4, 8. Now we're going to find the magnitude of that. So just the square root, -2 squared plus -4 squared plus 8 squared. And here it is, the square root of 84. This is the least squares error of example one. I have one more example, but I've somewhat expedited the process. So it says find the least square solution of AX equals B. Notice that's a much larger matrix A than in example one. But what I've done is I've went ahead and computed A transpose A, and I've computed A transpose B. So in other words, I know what to plug here, what to plug here. At that point, if you can just imagine that you have substituted here, you have substituted here, you would be at the point where you would set up a matrix and row reduce. So what I'm going to do is I'm going to give you the row reduced form. So again, park, just set up one large matrix uh, with 1, 2, 3, 4, 5 columns, 1, 2, 3, 4 rows. Okay, we go through that row reduction, and this is what comes up. So I see 3 pivots. And 1 free variable. So 3 basic variables, 1 free variable. All right. So for me, I go from here to the general form of the solution, right? So we establish, um, or I should say, we write the basic variables in terms of the free variables. And that would look like this. Now, it's from here that we have to produce x hat, right? That's x hat will give us the general form of all the solutions that we can reach. All right, so I've gone through this multiple times, and so I'm going to just go ahead and get us to where we need to be. Notice if you look at this, um, if you look at that general solution, we have, if you look at the right side of the general solution, we have both free variable x sub 4, as well as constants. So this is going to be of the following form. Right, so all the x sub 4s, let me go ahead and write it. So we would have negative 1, 1, 1, 1. All of them will take on that form. And then those constants would make up uh, that last column. It almost resembles y equals mx plus b, doesn't it? Interesting. Well, I hope that you were able to uh, gain some insight, gain some clarity. Not an easy subject. I agree with you. Absolutely agree with you. Um, if this is up your alley, if you enjoy this, there is quite quite a lot to do in linear algebra, and we have only skimmed the surface of the applications um, and the coursework. But I wish you the very best.